Hi everyone, my name is Farinam Hematizadeh and I am an MSc student in computer science at the University of Windsor. And today I'm going to present a joint work with Christine Bong, Alice Yu, and Hussein Fani on the paper titled Latent Aspect Detection by Backtranslation Augmentation. Researchers are mining for every word you write online, whether you write about a great restaurant meal or a low quality service that you receive. Review analysis involves collecting and studying user-generated contents across the internet. With using advanced language processing and data mining techniques, we try to uncover patterns, insights, and sentiments from the user and customers' conversations. But what make up these reviews? Let's say you go to a restaurant, you order pizza, and you do not enjoy the pizza. Then probably you will go to their Instagram or Google Maps page and leave a comment there saying that the pizza was a little burnt. You're giving a negative opinion about pizza, and your opinion is being a little burnt, and you're talking about pizza. Pizza is the aspect, what we call as an aspect, an attribute of a product or service that we give an opinion about. But why do we want to find these aspects? The reason is that they provide us with a comprehensive understanding of what customers like or dislike about the products or services that they are receiving. Let's say a large number of customers mentioned the pizza with negative opinion. So now the restaurant can take steps to improve the pizza that they are offering to improve their customer satisfaction. But how do we collect these reviews? The traditional way is sending email by the companies to the customers and asking for filling out some surveys or rating the experiences. So in this way, they will collect some solicited reviews. But unlike these solicited reviews, the other way that the customers prefer to do is the unsolicited reviews, in which they will voluntarily share their experiences in social media with their friends. But how does it differ with the solicited ones? Basically, these unsolicited reviews are more informal and short, as people share them voluntarily with their friends. And as they're being based on social background knowledge, they may miss some of the words. For example, in a review for a shop, you may say, she forced us to buy pricey dresses. You mean the seller, right? It is clear that you are talking about seller, and everyone can understand that you are talking about the seller. But you didn't mention the word seller explicitly. And according to the literature, approximately 35% of the reviews on restaurants and electronics are the same thing. They don't have any surface form of the aspect. In this situation, we call the aspect latent. So it is implicitly mentioned without any surface form. And finding these latent aspects is for sure challenging. But why do we want to find them? Because according to the literature, a large number of the reviews are unsolicited, just like every one of us do, like every day in social media. And these unsolicited reviews have latent aspects. So as the majority of the reviews are unsolicited, this is really important to find the aspects in these reviews. And so what? We want to find these aspects in unsolicited reviews. Existing methods in in aspect detection and finding the respective opinions and sentiments have been primarily expanded to two subtasks. First one is aspect term sentiment analysis, and the other one is aspect category sentiment analysis. In aspect term sentiment analysis, we extract explicit terms that point to an aspect by either tagging the terms or delineating the spans. And on the other hand, we have aspect categories in which we map a review into some predefined set of words, which are some coarse-grained categories. For example, if we have the review, my pizza was a little burnt, we find the category food and we find the term pizza. However, we have limitations in these aspect detection models. In the aspect term detection, we have the limitation that if the model has not seen the words of review before, it cannot find the aspect term. For example, if we have the contactless menu for restaurants in our review, and the model has seen the data sets before the contactless menu emerged, it cannot find it. And also, on the other hand, for the aspect category ones, they encounter limitation by a predefined set of words. So, for instance, while a category detection model may offer general labels like food, it falls short when the restaurants need precise insight to discern whether customers are discussing desserts, cocktails, or dish. And all of these aspect detection models are relying on explicit surface form of aspects, and they cannot find the latent ones. So we believe that we can improve the existing models without proposing a new model for finding the latent ones. And we believe that we can do this by augmenting the datasets in the training phase of the models. But let's say first briefly talk about what is data augmentation. Data augmentation techniques are some techniques that can enhance the training dataset and without the need to gather additional data. And it has demonstrated significant potential for enhancement across different domains like speech processing, image processing, and natural language processing. So we assume that this data augmentation can enhance aspect detection models to detect latent aspects. Basically, we have two types of augmentation methods. First one is rule-based one, which are some heuristics and a straightforward transformation. Like if you have the reviews through her chip behavior, it will, after if we give it to the rule-based model, it will give us her chip behavior through. And on the other hand, we have model-based ones in which we use a statistical model or machine learning algorithm to generate new data samples. And back translation is also one of those model-based methods for augmentation. And what is back translation? Let's say you can think of languages that they have commonalities and also they have differences, like how their words are putting together or how they mean, especially in everyday conversation. And now what is back translation is like playing with a language game. You start with a sentence or review in one language, you will turn it to another language, and then you will translate it or turn it back to the original one. This new sentence may have different wordings and may not have the exact words, but it will convey the same meaning. And it's like saying something in different way. And by this trick, we will make a bigger and more varied set of examples for our program to detect the aspects and learn from this data set. And as I explained earlier, we translate a review from its original language, let's say English, to another target language, for example, let's say French, and then translate it back to the original one, which was English, by a machine translator. And we presume this round-trip journey can generate diverse paraphrases of reviews while keeping semantics the same. First of all, we believe that it can reveal latent aspects, as they may not be commonly known in the target language. For example, if we have the review force us to buy pricey dresses by cheap behavior in English, and we use Farsi as a target language for the back translation, the word seller will shows up, and we will use it as a latent aspect. And also, we believe that it can address out of vocabulary aspects by augmenting context-aware synonymous aspects from the target language to the original language, as opposed to simply do the synonym replacement. For example, if we have the review serve me with the wrong dish in English and translated to Spanish and back translated to English, the word food will comes up compared to something like bowl or plate. And also, finally, we believe that back translation can disambiguate polysemous terms and collocations, leading to finding the latent aspects. For example, if we have the through her chip behavior, we translate it to Spanish and back translate it to English, we will have through her petty behavior, and now the petty is mapped for chip, which is more related to the behavior of a person compared to being related to being inexpensive for a product or clothes. And our current goal is to leverage this back translation technique to augment our training data set for review analysis for the task of the latent aspect detection. And this using back translation is not as straightforward as it may seem, as it has some problems and challenges. First one is the time that after the back translation, the meaning completely changes and it will go off topic. And also sometimes we will lose our labels as the words may change. So we have designed a control mechanism to find the new labels and remove the off-topic reviews. For the back translation phase, without the loss of generality to any machine translation models, we applied Meta's No Language Left Behind, or NLLB machine translator, which is an open source machine translator and is available open source publicly, and can provide us with high quality translations between 200 languages. And also for the semantic alignment, which is the second phase, we will remove the augmented reviews in which the semantic has been totally changed. Let's say if we have the review, the dog confit is always amazing about the food. After the back translation, we will see the dog crib is always fantastic, which is about furniture. So the meaning has completely changed, and we need to remove such reviews. So we have used the tool declutter in this case. And after that, for the term alignment, as it is clear, the wording after the back translation may change. So if we have the review serve me with the wrong dish, with the label dish, after the back translation, we will lose our label because we don't have the word dish anymore. So we will align the words with the tool in which we have used SimAlign, and we will align it with the new words in the back translation review. And now, if we had a review dish, if we had a review segment with the wrong dish and the label dish, now we aligned it with the word food, and now the label is food. And the three research questions that we have is first to see whether this back translation augmentation can improve the performance of aspect detection models, and also whether it can help the latent occurrences of aspects, and also to see whether it is cross-domain or not. To give you some statistics about our original data set, we have used some benchmark data sets in sentiment analysis, the version 14, 15, and 16 of the semi-val data set in two different domains, which are laptop and restaurant. And for the aspect detection model phase, we have used two different types of aspect detection models. First one is topic modeling ones, in which we treat each review as a document. So we will find the topic, and there are some highest probable words for that topic, which will be used as the aspects of the review. And also we have some benchmark baselines, which are some state-of-the-art words in aspect detection. And we want to see whether this augmentation can improve the performance of these existing aspect detection models. And as you see, these are the results for semi-val 15 restaurant data set for the precision, recall, and indecision metrics. And the first row is none, which is the results of aspect detection before the augmentation, and the rest for Chinese, Farsi, Arabic, French, German, and Spanish languages, we can see the improvement of aspect detection after the augmentation. And the last row is all, which is a combination of all languages, and we can see that we have the best results if we combine all the languages together. And in the aspect detection, as we don't have any latent aspect data set now, we try to mimic the latency by masking the labels. So if we have the review, the staff was friendly and patient, we mask the word staff, and now we have the was friendly and patient. And by mimicking the latency, we will try to have the latent aspect detection model, and then we will find some words, highest probable words with their probability. And now here we have the word staff with the highest probability, which is 0.6. And the success is that we find the aspect in the top K prediction of words. And also we wanted to see whether it can help the latent occurrences, and also whether it is cross-domain. As you see, we have the performance gain in latent aspect detection for all the data sets that we have for precision and indecision metrics. And as the plot suggested, even in 70% latency, which means that 70% of the reviews had latent aspects, we had improvement for the aspect detection models. And also these results are both for restaurant and laptop domains, so the improvement is consistent. And this is LADY, a benchmark framework to support the reproducibility of our research. And you can give it a try by using this link. And as a future works of this research, We will experiment the backtranslation augmentation on lower source languages, as we think they can add more to English, and also we will add new unsolicited datasets such as Twitter or other social media. Thank you for listening.